What's up, scholars? Welcome. Today we are talking about the unit circle. Now, today is a really special day because we're going to combine another one of my loves, geometry, into this lesson about the unit circle, which kind of makes sense because a circle is a shape that we often talk about in geometric terms. We're going to recall our special right triangles and our trig ratios for this. So first, our special right triangles. We had a 30, 60, 90 triangle, a 30, 60, 90 triangle, called such because those are the angle measures that we have. And this 30, 60, 90 triangle, the side lengths had special ratios. So if the side, the shortest side across from the shortest angle, which is 30 degrees, that side, if that was 1 unit long, then the hypotenuse was twice as long as the shortest side. So it would be 2 units long. And the middle side across from the 60-degree angle, that was the square root of 3. This was our special ratio with our special right triangle, 30, 60, 90. The side across from the 30, if that is 1 unit long, the hypotenuse is twice that, 2 units long. And the side across from the 60 is the square root of 3 units long, and it will always be in this ratio. Now, our other special right triangle was a 45, 45, 90 triangle. 45 degrees here, 45 degrees here, 45, 45, 90 triangle, 45, 45, 90 triangle. This is an isosceles triangle. Got these 2 angles that are equal to each other. So these 2 sides will be equal to each other. So each of these were 1 unit long because they're going to be the same length. It's an isosceles triangle. The hypotenuse was the square root of 2 units long. And you could confirm all this using the Pythagorean theorem, certainly, because 1 squared plus the square root of 3 squared, which would be 3. 1 plus 3 would be 4, which is 2 squared. So a squared plus b squared equals c squared. And same thing here. 1 squared plus 1 squared, well, that would be 1 plus 1 is 2. So 1 squared plus 1 squared would be the square root of 2 squared, which is 2. So here are special right triangles that we are recalling from our geometry days. And then I also said we were going to recall our trig ratios, which were sine, cosine, and tangent. So the sine of some angle theta is the ratio of its opposite side over the hypotenuse. The cosine of some angle theta is the relationship of its adjacent side over the hypotenuse. Hopefully this is ringing some bells. And then tangent of some angle theta, running out of space, doing fine, is the ratio of the opposite side over the adjacent side. Then we had a mnemonic to help us remember this, which was SOHCAHTOA. Where does that come from? Well, sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. So to talk about this unit circle, we are recalling our special right triangles, our 30, 60, 90, and 45, 45, 90, and their special relationships of their sides, as well as our trig ratios, our sine, our cosine, and our tangent. All right, here we go. All right, to help with the discussion of the unit circle with these special right triangles, I made these little cutouts. So let me show you what's going on here. So I've got the cutout of the 30, 60, 90 triangle with the angles very tinily written in there. That's our 90-degree angle. Across from the 30 is the side that is 1 unit long. Across from the 90 is the side that's 2 units long, and across from the 60-degree angle is the side that is the square root of 3. Remember, these are the ratios of the sides. 1 to square root of 3. Then of course also got the 45, 45, 90 triangle, which I drew the opposite direction. I don't know why, just what happened. So we've got our side across from the right angle, which is the square root of 2 units long, and the other 2 sides across from the 45-degree angles are both 1 unit long. So I'm going to use these little cutouts in our discussion of the unit circle. So here we go. Unit circle is a circle with a radius of 1. So go ahead and draw a reasonably large circle on your paper, centered at 0 in the XY axis. Unit circle technically has a radius of 1. All right, so we've got our unit circle centered 0, 0. Its radius is 1. We're using these little cutouts here, and we're going to be able to find the sine, cosine, and tangent of angles related to these special triangles really easily using this unit circle. So let's say, for example, we're going to find the sine, cosine, and tangent of 30 degrees using the unit circle. So I'm taking my 30, 60, 90 triangle. I'm going to set it up here. So this is 30 degrees around the circle. Right, here's our 30-degree mark. This would be 30 degrees around the circle. We're starting at 0, 30 degrees around the circle. Set that guy up. So let's see here. We've got the sine of 30 degrees. Now, what was sine? That was the opposite side over the hypotenuse. So the sine of 30 degrees is 1/2. How do we get that? Well, the opposite side is 1, hypotenuse is 2, so 1 over 2. How about the cosine of 30 degrees? Cosine of 30 degrees is the adjacent side, which is the square root of 3 over the hypotenuse, which is 2. Square root of 3 over 2. Square root of 3 over 2. And what's the tangent of 30 degrees? Tangent of 30 degrees is the opposite side over the adjacent side. Tangent of 30 degrees is 1 over the square root of 3. And as you may recall, having a square root in the denominator, no go. So the way we fix that is called rationalizing the denominator, or multiplying on the top and bottom by that square root. And when we do that, we get 1 times the square root of 3 on the top, which is the square root of 3, over square root of 3 times square root of 3 is just 3. So we used our unit circle and our special right triangles to very quickly find the sine, cosine, and tangent of 30 degrees. Now we can do the same thing with, let's say, 60 degrees. Flip my triangle over so I can go up here. 60 degrees, that's going to be right here. 60 degrees. Let's do the sine of 60 degrees. What's sine? It's the opposite over the hypotenuse. So the opposite side to 60 is square root of 3 over the hypotenuse, which is 2. Square root of 3 over 2. What's the cosine of 60 degrees? Cosine is the adjacent side, which is 1 over the hypotenuse, which is 2. 1 over 2. And tangent of 60 degrees is going to be the opposite side, which is square root of 3, over the adjacent side, which is 1. Square root of 3, square root of 3, over 1. If something is over 1, we don't need to write it, so we could just say the square root of 3. Now you'll notice these are related to each other here. These are definitely related to each other here. Namely, the sine is the same as the cosine of its complementary angle. Sine and cosine of complementary angles are equal to each other. All right, let's check out our 90-degree triangle and use that to find information about 45 degrees, which should be right in the middle there, 45 degrees. Great. Okay, let me see if I slide this up. Awesome. So let's find the sine of 45 degrees. Well, sine is opposite over hypotenuse, so 1 over the square root of 2, 1 over the square root of 2, which we know we can't have a square root in the denominator, so we're going to multiply by square root of 2 or square root of 2 and get the square root of 2 over 2. How about the cosine of 45 degrees? Well, cosine is adjacent over hypotenuse. Well, we just did 1 over the square root of 2. We already know that that is square root of 2 over 2. Cosine of 45 degrees, same thing, square root of 2 over 2. And how about the tangent of 45 degrees? Tangent is opposite over adjacent, so 1 over 1, which is 1. Sweet, nicely done. Okay, so that worked great for angles that were in the first quadrant. What about angles that are not in the first quadrant? Let's say, for example, 135 degrees. Well, that would be 90 plus 45, right? 90 degrees plus 45 degrees would get us to 135 degrees, but we're using our reference of a 45-degree angle. So let's talk about the sine of 135 degrees. Okay, sine of 135, sorry, is still opposite over hypotenuse. Now we got to pay attention to the coordinates here. So this is still a positive y, so that's still a positive 1, but our x, that's really a negative 1 now because we're in the negative x zone. So we'll have to keep that in mind when we're looking at this side specifically. That's really a negative 1 now because we're in the negative x values. But sine is opposite over hypotenuse, so that's 1 over the square root of 2, which we previously solved and showed that that was square root of 2 over 2. Square root of 2 over 2. How about the cosine? Cosine of 135, that's adjacent over hypotenuse, but this adjacent side is really a negative now. So this is negative 1 over square root of 2 because we're in the negative x values. So negative 1 over square root of 2 is going to become negative square root of 2 over 2. And finally, the tangent. Tangent of 135. Opposite over adjacent. Opposite one is positive. The adjacent one is negative. So 1 divided by negative 1 is negative 1. Excellent. All right, let's try another one in the second quadrant. Let's say we're looking for 90 plus 30 more degrees. It's going to get us to 120 degrees. So we've got our 30, 60, 90 triangle that we're using. Now notice if this was 30 degrees, that was our extra 30 degrees. I've got 60 here. That's my reference angle, not 30. Because 30 is what we're adding to this 90 degree. Right? 90 degrees plus 30 is 120. But to make this reference triangle work, I've got to put the 60 here. So that 30 degrees lines up with 30 here. And to make a right triangle off this point, my 60-degree angle is what we're actually looking for. So the sine of 60, or sorry, not 60 degrees, the sine of 120 degrees. The sine of 120 degrees, which is related to the 60s. Sine of 120, going to be opposite over adjacent. This square root of 3 is still positive because it's a positive y value, right? We're on the positive y-axis. Square root of 3 over 2 cosine of 120 degrees. That is the adjacent side, which is 1, but that's a negative 1. So there's going to be negative 1 over hypotenuse 2, negative 1/2. And the tangent of 120, opposite, square root of 3 over adjacent, negative 1, negative square root of 3 over 1, or just negative square root of 3. Now let's do this again one more time with our triangle here. So this is 120. Those were 135. This guy's going to be 90 plus 60. It's going to get us to 150 degrees, right? If this is 60 degrees, then our reference angle here is really 30, the complement of that. Now we've got this set up. We know that's a positive 1. That's a negative square root of 3, because that's in the negative x direction. Keep that in mind. So sine of 150 opposite over adjacent, 1 over 2 cosine of 150. I just said opposite over adjacent for sine. I meant opposite over hypotenuse. But cosine is adjacent, negative square root of 3 over 2. Negative square root of 3 over 2, and tangent of 150. Opposite over adjacent, 1 over negative square root of 3, 1 over negative square root of 3, which we know we need to multiply by square root of 3 to rationalize this denominator. Slide that guy over. It's going to become negative square root of 3 over 3. Awesome. So let's quickly walk through how we would form right triangles to find our other major angles of reference. So if I flip my triangle down here, this is going to be how much? Well, this is 180 plus 30 degrees, which is 210. And then I would have our, come on, buddy, here we go. 180 plus 60 degrees would give us what is that going to be? Oh, right, 240. We could have in the last quadrant here. This is going great. There we go. And let's think about this in our opposite direction. So this was 0 degrees. If I go 30 below it, 30 degrees below, right? So I got my right triangle coming off this x-axis, 30 degrees below. And that would be negative 30 degrees, or 360 minus 30 would be 330. 330 degrees. Get my here. You guys are doing great. Zero degrees here. I've got my right triangle coming off the x-axis. Subtract 60 degrees from 360, so we're going in the other direction. What's that going to be? 300 degrees. Okay, so I'm just showing you how you're making your right triangles off of your axis on your unit circle. And then we've got our 45, 45, 90s, which are a little bit easier. Right triangle, right angle off the x-axis. This guy's going to be right in the middle at 235 degrees. And here, right in the middle at 315 degrees. Excellent. So we can use these triangles to help us find our sine, cosine, and tangent of any of these angles. All right, so those special right triangles work super well for all of these angles. But what about 0 degrees and 90 degrees and 180 degrees and 270? How about those guys? So for these ones, we're going to consider the coordinates of these points. The coordinates of this point are 1, 0, right? Why is that? The radius is 1. The coordinates of this point, the 90-degree angle, are 0, 1. The coordinates of 180 are -1, 0. And the coordinates at 270 are 0, -1. And the rule we're going to use here is that the sine of the theta is going to equal the y value of the coordinate. And cosine of theta is going to equal the x value. So our sine of 0 degrees, the y value of 0 degrees is 0. And our cosine of 0 degrees, the x value is 1. So the sine of, let's go up to 90, sine of 90 degrees, what's the y value here? Well, that's 1. Cosine of 90 degrees, x value is 0. Sine of 180, what's that going to be? Well, that's the y value. The y value is 0. How about the cosine of 180? That's the x value. That's -1. And 270, sine of 270, what's the y value here? That's -1. Cosine of 270, x value is 0. And if we said 360, we'd be back. That's the same thing as 0. It's the exact same thing. Sine of 360 equals 0. Cosine of 360 equals 1. Excellent. All right, so as a quick recap, for our intro to the unit circle, we talked about using special right triangles to help us find the trig ratios real quickly on this unit circle. We found the sine, cosine, and tangent of various angles using those special right triangles. We were careful when we had angles that were outside of this quadrant 1 because sometimes their values are actually negative, right? So our sine or our cosine of 120 degrees was -1/2. And then for our values for 0, 90, 180, and 270, we said the sine is going to be the y value and the cosine is going to be the x value. Nicely done, scholars. Good job, everybody. Keep on that hustle, and I'll see you next time.